Hi students, I am Sandhya, Assistant Professor, Department of Mathematics. Today we are going to see diagonalization of a real symmetric matrix. So in this diagonalization of a real symmetric matrix, mainly used to data analysis. In this data analysis, if it is a large data, we are going to using the diagonalization. The data is compressed in the shortest form. If it is compressed in the shortest form, the data lossing is minimization. That's why we are going to using the diagonalization. So in the diagonalization format is the diagonalization is D equal to N transpose A into N. Okay, so here what is N and what is N transpose? N is a normalized model matrix and A is a given matrix. So in this given matrix we have to find the eigenvalue and eigenvector. Using this eigenvector we have to find the normalized model vector. So using this normalized model vector we have to find the normalized model matrix, that is the N. Okay, so the process of finding N is a diagonalization. Okay, next the following steps are using the diagonalization. Okay, so if it is for example, so this is a given matrix. For example, 6, 7, 2, 3, 5. So this is a given matrix. If it is, we have to apply the diagonalization. So the matrix is converted as D equal to 0, 0, here also 0, 0, 0, 0. Only we are going to occur that eigenvalue, that is the diagonalization. So in this matrix is converted as, that is diagonalization. Here the value is occurring in the diagonal. So that is the eigenvalue. Okay, so in this process diagonalization, the following steps are we are going to use. So first we are going to see what are the steps. First step is using in this matrix we have to find the eigenvalue and eigenvector. So how we can find the eigenvalue? Eigenvalue is nothing but first we have to find the characteristic equation. So the characteristic equation in the 3 by 3 matrix is, what is that? Lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. We have to find the C1, C2, C3. Then the equation is rearranging the C1, C2, C3. Then we have to solving this equation, we get the eigenvalue. So this is the second step. Okay. So in this eigenvalue, using we have to find the eigenvector. What is that eigenvector? Okay. So next, if it is find the eigenvector, then we move on. The eigenvector is a pairwise orthogonal. What is the pairwise orthogonal? Pairwise orthogonal is nothing but x1 transpose x2 equal to 0. Okay, x2 transpose x3 equal to 0. Then x3 transpose x1 equal to 0. So if we check left hand side, then we get the right hand side, that is 0. It is a the given vector is a pairwise orthogonal. Okay, then we move on the third step to form the normalized eigenvector. So in this for example, this is the one vector 1, 2, 4. So this is the eigenvector. We have to form the normalized eigenvector. How we can find the normalized eigenvector? First we have to using this is x1, this is x2, this is x3. Okay. So here generally x1 divided by L of x. Next x2 divided by L of x. Next x3 by L of x. Okay. So here x1 is 1 and x2 is 2 and x3 is 4. So what is L of x? L of x is nothing but our x1 square, x2 square, x3 square. Okay. So here root of 1 square plus 2 square, that is 4 square, that is the L of x. Then we have to divide 1 divided by L of x and 2 divided by L of x, then 4 divided by L of x. Okay, so here this is the normalized eigenvector form. Okay, then using this normalized eigenvector, we have to combining 3 vector. Okay, for example, x2 is 6, 7, 8. Okay, using this x2 we have to find the normalized eigenvector. Okay, then x3 is another normalized eigenvector. So combining, for example, 4, 6, 7. If it is combining all the eigenvector, normalized eigenvector x1, x2, we combining, we have to form the another new matrix, that is the normalized model matrix. Okay, then if we have to find the normalized model matrix, then we have to, that is normalized matrix is denoted by the symbol as n. Then n should be orthogonal. So we have to check n is a orthogonal or not. So how we can check? N transpose n equal to I. Similarly, n transpose equal to I. Okay, so if we know the n value, then multiply n transpose, we get the answer is 1 0 0 0 1 0 0 0 1. Okay, so that is n is a orthogonal. Then we have to using d equal to n transpose. So you get the n known as, so we have to substitute n and n transpose. So A is a given matrix. So we get the diagonal form. Okay, thank you.